Hello, I'm Benjamin Montone, and this is my senior design project for Rutgers University. Basically, our project is called DangerBall, and it's basically to develop a sensor package that will help us understand the interior of buildings.
My name is Sean Puri, and I work on the DangerBall project. And right now I'm going to give you an overview of the system architecture we use for the project. So the main idea was to develop a sensor package, as I said before. Basically, we have three main sensors. We have the two IMUs, two ultrasonic distance sensors, and two webcams. The way this works is we have two main components here, the Raspberry Pi and the Arduino. The Arduino microcontroller controls the ultrasonic distance sensors, and Raspberry Pi is connected to the Arduino, the IMUs, as well as the webcams. The way the data works is the data is streamed continuously from the sensors to the Raspberry Pi, where it's packaged into files and time-stamped, and then sent wirelessly to a processing station in order to do post-processing, like display graphs.
Hi, I'm Neeraj Venkatesan, and I'm going to talk a little bit about some of the implementation challenges we faced throughout this project. The two webcams are being controlled by the Raspberry Pi, and the processing power of the Raspberry Pi is severely limited, so even though we can successfully get a dual stream, the resolution is not quite what we would have hoped. Furthermore, implementing the IMUs proved to be quite difficult, as the documentation was not necessarily there for what we wanted, so we had to empirically test these to obtain the real-world scalings from the data to actual units such as G for acceleration, which is 9.8 meters per second squared, or degrees per second for the gyroscope. And we have implemented a live plotting program in MATLAB which can take this data stream, which would be coming in wirelessly in this architecture, and plot it as the data comes in. And when we move this whole sensor platform, we can see the appropriate peaks in the graph. So some of the future applications we have for this project are we would fuse the accelerometer and gyroscope data coming out between the two IMUs to sort of reduce the jitter that we see in some of these plots. Continue researching portability to put this into a ball-shaped object, as the title implies, with the appropriate casing and impact-resistant padding. And we'd like to use the two video sensors to get some sort of stereo vision application to better correlate all of this data in an integrated fashion.